Hello everybody, welcome to this class on three-dimensional geometry. We will be discussing planes and the basic Cartesian and vector form of a plane. So the basic form of an equation of a plane is given by r dot n cap equal to p, where p is the length of the perpendicular from the origin to the plane and n cap is a unit vector now perpendicular to the plane. So remember that n cap has to be a unit vector. If n is just a vector perpendicular to the plane that is not a unit vector, we make it a unit vector by dividing it by its modulus, and we write n cap as n by mod n. In this case, the vector equation of the plane will be r dot n equal to d, and this is the vector equation of the plane. What about the Cartesian equation? Cartesian equation is given by ax plus by plus cz equal to d, where a, b, c are the direction ratios of the normal to the plane. Now, if you have an plane passing through a point A and perpendicular to n, the vector equation will be r minus a dot n equal to 0. Again, if the point is x1, y1, z1 and a, b, c are the direction ratios of the normal to the plane, the Cartesian equation will be a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. So coming to questions, find the direction cosines of the perpendicular from the origin to this plane r dot 6i minus 3j minus 2k plus 1 equal to 0. First find the direction ratios of the normal, that will be 6 minus 3 minus 2. So we divide it by the modulus, that is root of 36 plus 9 plus 4, which is 7. And then the direction cosines will be just divide each term by 7. So it will be 6 by 7 minus 3 by 7 and minus 2 by 7. Coming to the next question, find the equation of the plane such that the length of the perpendicular from the origin to the plane is 5 units. And this perpendicular makes angles 60 degrees and 45 degrees with x and y axis respectively. So I need to use the formula r dot n cap equal to p. So we need a unit normal. Direction cosines of the unit normal are given by cos alpha, cos beta, cos gamma. This is another formula where alpha, beta, gamma are the angles made by the normal with the x, y and z axis respectively. We also have cos squared alpha plus cos squared beta plus cos squared gamma is 1. So substituting, we get cos squared 60, which is 1 by 4, cos squared beta, which is half, plus cos squared gamma is 1. So simplifying, you get cos gamma equal to half. Now we have to find the equation of the plane in the form r dot n cap equal to p. So we need to calculate n cap. N cap is cos alpha, cos beta, cos gamma. So we have cos 60, cos 45, and what is cos gamma? It is half. So substituting, we get it as 1 by root 2, cos 45 is 1 by root 2 and half. So equation of the plane will be r dot n cap equal to p. That is r dot 1 by 2i plus 1 by root 2j plus 1 by 2k equal to 5, where p is the length of the perpendicular. Coming back to the question, you are given that length of the perpendicular from the origin to the plane is 5 units. Okay, next question. Find the vector equation of the line passing through 1, 2, 3 and perpendicular to the plane r dot I plus 2j minus 5k plus 9 equal to 0. So vector equation of a line is given by a plus lambda b, line passing through a and perpendicular to n. Now here the line is passing through 1, 2, 3. So it will be I plus 2j plus 3k plus lambda times I plus 2j minus 5k, because direction ratios of the normal to the plane will be I plus 2j minus 5k, which will be the direction ratios of the line. So you can just simplify this. So we can take the terms in ij together. So you get 1 plus lambda I plus 2 plus 2 lambda j plus 3 minus 5 lambda k. Coming to the next question. Find the distance of the point 1 minus 2, 3 from the plane x minus y plus z equal to 5 measured along a line parallel to the line x minus 1 by 2 equal to y minus 3 by 3 equal to z minus 2 by minus 6. So first we find the equation of the line plane of the line passing through 1, minus 3, 1, minus 2, 3 and having direction ratios 2, 3, minus 6 because the line is measured parallel to this line. So direction ratios of the line will be same as direction ratios of this line, which is 2, 3, minus 6. So using the Cartesian form of an equation of a line, equation of the line will be x minus 1 by 2 equal to y plus 2 by 3 equal to z minus 3 by minus 6. Now we have to find the distance of 1, minus 2, 3 from this plane. Now let this line intersect the plane at P. So we can say let x minus 1 by 2 equal to y plus 2 by 3 equal to z minus 3 by minus 6 equal to lambda. This was the equation of the line which you got. So simplifying, you get x equal to 2 lambda plus 1, y equal to 3 lambda minus 2 and minus 6 lambda, z equal to minus 6 lambda plus 3. So this line, that point, that is 2 lambda plus 1, 3 lambda minus 2, minus 6 lambda plus 3 will lie in the plane if it satisfies the equation of the plane. So substitute the values in the equation of the plane and we get lambda as 1 by 7. And now coming back and substituting here, you get your point of intersection as 9 by 7 minus 11 by 7 and 15 by 7 and then use distance formula from 1 minus 2, 3 and find the distance of the point. So we have to find the distance of the point using distance formula, that will be 1. I'll do one more question and stop. Find the image of a line in the plane. Line is x minus 1 by 3 equal to y minus 3 by 1 equal to z minus 4 by minus 5. In the plane 2x minus y plus z plus 3 equal to 0. So first we find the 1, 3, 4 is a point. We find the image of 1, 3, 4 in the plane. So direction ratios of the normal to this plane will be 2, minus 1, 1 and equation of a line passing through 1, 3, 4 and having direction ratios 2, minus 1, 1. We actually don't need this fact that 1, 3, 4 is a point in the plane. So this I will just erase for now and we have direction ratios of the normal to the plane are 2, minus 1, 1. So we will write it as 2, minus 1 and 1 and equation of the plane passing through 1, 3, 4 and having direction ratios 2, minus 1, 1. Equation of the line will be x minus 1 by 2 equal to y minus 3 by minus 1 equal to z minus 4 by 1. As discussed earlier, we will find the point of intersection of this line with the plane. So again let x minus 1 by 2 equal to y minus 3 by minus 1 equal to z minus 4 by 1 be lambda. So x equal to 2 lambda plus 1, y equal to minus lambda plus 3, z equal to lambda plus 4. So this is similar to the previous problem. And substituting these points in the equation of the plane, what is the equation of the plane? 2x minus y plus z plus 3 equal to 0. We get lambda is minus 1. And then coming back here and substituting, the point of intersection will be minus 1, 4, 3. So the image of let the image of 1, 3, 4 be ABC. Now the point of intersection is the midpoint of the point and the image. So using midpoint formula, you get a plus 1 by 2, b plus 3 by 4, c plus 4 by 3 is minus 1, 4, 3 because the original point was 1, minus 3, minus 4. Solving, we get a is minus 3, b is 5 and c is 2. So your image is minus 3, 5, 2. Now we have to find the image of the line. So the line has direction ratios 3, 1, minus 5. So equation of the line will be x plus 3 by 3 equal to y minus 5 by 1 equal to z minus 2 by minus 5. So we have done quite a few tricky problems in the vector and Cartesian form of a plane and also revised equation of a line. Thank you.